let me first explain who I not am. So I'm not Eric Peckwith, who excuses himself for family commitments. And I'm also not Paul Pedersen, who is moving apparently to the Max Planck Institute. And I'm also not Jan Willem Romein. But I am Hans van Dipmers, and you will see more of me this week. And the talk is indeed, when is an example a counterexample? And I've, of course, done my best to give the, well, to bring now the ideas across of these authors of this original work. To start with, I'll start with this citation from Stalnaker, which I'll read aloud because it's sort of the motivation of their presentation. So, so what they are concerned with is the role of examples and counterexamples in modeling rational inquiry. A situation of rational inquiry, the idea is to account for the information about how I learned some of the things I learn, about the sources of my information, or about what I believe and don't believe. And if the story we tell in an example makes certain information about any of these things relevant, then it needs to be included in the proper model of the story if it is to play the right role in the evaluation of the abstract principles of the model. So this is in a recent work by Stalnaker called Iterated belief revision, which is relevant to mention in this setting because it contains a number of principles of iterated belief revision. Now, why is it relevant here why is iterated belief revision here relevant? Well, the examples and counterexamples are in the setting of iterated belief revision, but as you might recall in the 8 AGM principles for belief revision, there is no talk about iteration, right? The last two are, well, they're about belief revision with respect to two different formulas, but then how, when combined in a conjunction, they relate to revising with one only and then relating it to the deductive consequences of adding yet another of these two. Yeah, but there's no actual iteration of two revisions. So this made the community, propose various ways to expand this with reasonable principles for belief revision. And this project failed for a number of reasons. And those are two of these principles here proposed by Stalnaker. And the first one is that it's the one I1. So if we have phi that already follows from, psi follows from phi, then if we first do a revision with psi and then with phi, well, then you might have well done it with phi straight away. So if we already have phi implies psi as a theorem, with respect to the background theory K here, then if you first learn psi and then the stronger phi is followed after that, well, you could have well done it straight away by phi. Well, one supposed postulate. Another supposed postulate, well, if actually psi contradicts phi, then if you first have a belief revision with phi and then with psi, well, and if you take that new psi as the real thing, well, if it contradicted phi, you might have well done it straight away, right? So you might as well do a revision with psi straight away. When I read this, like preparing my way to present these slides, I thought, but this is hugely counterintuitive, right? Because so this predicts what's going to be found on the next slides, and we're going to contradict the presentation. So let phi be a conjunction of 1,000 strong facts. Then you find one in contradiction with those 1,000 facts. Then you throw away all these 1,000 facts. That's what this principle I2 is saying, right? So we have belief revision with phi. It can be many things. Then you have a contradiction found in the consequence of phi. That could be one of these many things. Well, then you take only the last new bit of information, you throw away all the previous. Okay, it's a principle. But the idea is here that you are looking to extend the AGM framework by staying on the same level of, you might say, a binary decision on acceptable or not acceptable in a set of beliefs by first principles. Where does this lead to? And the authors propose here a number of alternative proposals. Well, first, following on the dead end where this leads to, one of them being possibilistic, the other probabilistic, and yet another one epistemological. Okay. So this is a nice counterexample, and let's look at this in some detail. So we have two fair coins. They are flipped. they're placed in two boxes, and two independent and reliable observers deliver reports about the status, heads or tails. So first we have that Alice reports that the coin is heads, and Bert reports that the coin is also heads. Okay, makes for a belief revision, right? Both will be heads up. Then you have two new witnesses, Carla and Dora. Carla says that the coin in box 1, no, it's actually tails. And Dora reports that the box in the coin 2, no, it's also tails. Okay, so the first two observers say both it is heads, and they're different observers, so it's supposed to be independent. Then the next two observers, both yet two new persons again, so more independent observations, so to speak, they both actually contradict both observations, and they're saying that it's both tails. Okay, now here comes the aspect of the counterexample. Now there comes a fifth observer, Elmer. Well, reputedly a very reliable witness, and he says that the coin in box 1 is actually heads. How are you going to revise your beliefs based on this fifth observation? Well, the next transparency will give the model, but let us reflect, just reading this description, what will happen, right? So Elmer only makes an observation on the coin in box 1, but not on the observation of the coin in box 2. You might say, given that we have seen these four observers already, I'd say that the status quo was that it's tails in box 2, right? So an independent observation on box 1. Would you like this to affect your beliefs of what is in box 2? Well, maybe not. Well, at least it would be heads or tails. You have to make a decision here. Yeah, but you could have arguments to say, well, Elmer, he's, after all, our last, most reliable overall witness, so why, given that these boxes and outcomes seem to be not so independent as we thought, because it was both heads or both tails, well, maybe they're indeed related. They're not independent, right? So then the last observation of heads in box 1, that suggests that maybe box 2 should also be heads. Anyway, well, first question, would these observations be consistent with the two proposed principles by Stoldaker that I just showed? Well, no, they are not, and therefore it's a nice counterexample. So let us model the HI as the coin in box I is lying heads, and TI as the coin in box I is lying tails. And the original belief set, you might say the original belief set is empty. Now we have the first two observations, head 1 and head 2. So we have a K prime that is K revised with head 1 and head 2, and then contains this head 1 and head 2. Okay. Now we have two more independent reports by Carla and Bert, C and D, that no, it's tail both in 1 and it's tail both in 2. Then we have a fifth report by Elmer, who says, no, actually it's head in 1. And so we first have H1 and H2, then we have a further revision T1 and T2, and then we have a further revision H1. Okay, first argument. Since Elmer's report is irrelevant to the status of the coin in box 2, it seems natural to assume that 2 is tails is still in the belief set. So, as it says here, so that at least that box 1 is now heads and box 2 is now tails, should be in the, well, final outcome, which is the sequence of these three revisions. Okay. Other explanation. Well, since head 1 is in contradiction with the second revision, tail 1 and tail 2, therefore, by application of the proposed principle I2, it prescribes that first revising by T1 and T2 and then by head 1, because of that contradiction, should go straight away to revising with head 1. Okay, but then it must be heads in 2 as well, and not tails. And so we have an argument to derive that box 2 contains tails, and we have an argument to derive that box 2 contains heads, and they seem to contradict. And which of these two would be therefore the best to proceed? Well, as I already, well, somewhat tentatively suggested, that of course these two things here could be 1,000 things, and if you have one contradiction, then why should I throw away all these 1,000? That's just a generalization of here throwing away the second, right? So, yeah, sure.
The way in which you state the problem, you say Elmer is the most reliable, right? But the,
yes.
But the semantics of AGM and belief revision has no semantics for most reliable. If Elmer had spoken first, he would be outbid by the other two people, right? It depends only on the order. There is no semantics for most reliable.
Yes, I agree entirely with what you say. So I'd say that an implicit assumption in AGM is that the last witness is always the most reliable.
Right.
So the last evidence you receive supersedes all prior evidence, because it reflects the moment you have already decided that it was most reliable and the consequences of incorporating that after that decision. Yes. Yeah. Yeah, and another thing that is not modeled here, I thought you were going to mention that, is that I'm talking here about different witnesses, right? So so far I'm not modeling any agency aspect of the different aspects of information coming here towards you. So this might come at the end. Yeah. Okay. Well, I wanted to show this, but prior to that, sorry. So they propose, you might say, 3 ways to address this problem. For the authors, the problem here is that it is difficult to provide a policy for iterated belief revision by first principles, AGM style. Just determine what the new set of beliefs will be, given that you know what the current set of beliefs was. Well, various solutions have been proposed for in the literature, of course, over the last 20, 30, even more years. One way is to have background preferences on, well, if you revise something, which comes first and which comes then second, in case you have to make a choice. If you keep heads or tails, you do this with reference to some background, well, preferences. Well, you could call that plausibilities, or you might say this is the possibilistic approach. Well, not so unsimilar to what we have just seen in Ivan Vacichak's presentation. Then the second idea is also one with a background in this area and in AI, in books like Reasoning About Uncertainty, is you could have a probabilistic approach where you, instead of, well, plausibilities, you bring probabilities into play, and then it becomes less or more plausible that you have heads or tails, well, with a certain probability. Where in this probabilistic approach, they distinguish both, you might say, the standard and the non-standard probabilistic analysis. The non-standard probabilistic analysis then comes a bit closer to the initial qualitative approach of the AGM style, because then the small probabilities become negligibly small, so to speak. Then the third approach, you might say, is more the epistemological way to get out of this dilemma, well, by a more involved philosophical argument, to which I hope to get at the end. So let's first start with the plausibilistic way to address these matters. And then we can observe here that I think this is still a bit fairly loud, or is it okay? Is it okay? Okay, yeah. But the problem is that if it's too loud, it annoys it annoys myself when I'm speaking. This is always a bit of an issue. Okay. So instead of, so I'm analyzing the example here, where we have 2 boxes that contain either a heads or a tails. We can see this as a number of, combinations of valuations of propositions describing whether it's heads or tails in box 1 or 2, where we have 4 possibilities. And initially it can be both heads, it can be both tails, it can be heads and tails or tails and heads. All is possible, so to speak. Then by our subsequent process of belief revision, this is inducing, you might say, a plausibility between our stronger or weaker beliefs among these different valuations. And of course, if the first observations, well, by A and B combined for H1 and H2 are as such, then the next state of information here becomes one where it's more plausible, more likely that they're both heads than not. So the all three are like considered less likely, so to speak. Then the next observation by C and D that it's both tails brings us, by adopting the similar policy, to the one where this now becomes most preferred and gets to the bottom, but where we actually then keep the preference among the remaining valuations. So it remains the case that H1 and H2 is more plausible than, well, what's still remaining up there, which was T1, H2, and H1, T2. So actually I'm applying a belief revision policy with respect to a plausibility order, which is called radical upgrade. You could have different policies, for example, conservative upgrade. So far we see no difference, but with the final step in this three-step iteration, we will see a difference, because the final step of the iteration was when Elmer, and this is E for event, not E for Elmer, when Elmer says, no, actually in box 1 it was heads, and if in box 1 it was heads, then now both situations wherein box 1 contains heads become more plausible than the others, but we might as well keep our plausibility relations between the valuations for the remainder as it already was. This is not sounding very clear, so let's look at the event heads given these four valuations. That is this one, because here one is heads, and this one, here one is heads. So that's H1, H2, and H1, T2, right? But we have that H1, H2 is more plausible than H1, T2. So therefore, we now make both of these, by this radical upgrade revision policy, more plausible in the final ordering. H1, H2 comes below, more plausible than H1, T2. And the remainder, which was T1, T2, and T1, H2, well, is on top of that, less plausible than the H1 options, but also while keeping the same order, that T1, T2 is more plausible than T1, H2. Okay, so here we have a final plausibility ordering, and if in this case you were to have a different revision policy, for example, a conservative upgrade, you would take only the most preferred of the H1 worlds, and then the H1, H2 would come on the bottom singly, while having T1 and T2 on top of that. Yeah, but there's some variations there. Okay, well, at least I've talked my way through the picture, while ignoring the text written on the side, which I hope you have written in the, read in the meantime. But the morale of this is that at least by this way of revising based on the valuations, you can, well, it's a way of assuming independency of the observations while focusing on the situations solely, and therefore it's a particular choice for modeling this problem. Okay, let me continue now with a different a different approach, and let me not forget to mention the morale that the authors give to this part of the story. So each step of this belief revision, each step of this three-step belief revision actually keeps assuming that the positions of the coins under these cups. We do this while not assuming any background of plausible or probability, plausible or probable orders on the information available. Well, the answer to that is no. But you can then too. You can then make it to agree with the scenario, but well, not furnish a systematic way to formalize the relevant meta-information. Meta-information here actually means higher order epistemic information, or at least that's how I interpreted this. You can do this, but then if you do that, then you make other strong assumptions, for example, on the independence, where you might also want to model that actually the observations between these two cups are dependent. And in that framework, that is not yet not possible. For that, you might then, want to choose some alternative option, like doing it in a more probabilistic way. Therefore, they also provide a solution. I'd say that, I have also read the actual paper, of course, a couple of times before giving this presentation. So the probabilistic aspect of their paper, I find that the strongest contribution they make to address this problem. So here I have to be even a bit more schematic about talking my way through the information here, because the slides I have I hope they won't kill me after this talk, but so I gave strict orders to Eric Peckwitz, yes, I want to give this presentation, but give me 10 slides only, or I won't do it. So he made a big reduction of this information, and so he removed the schemata that are in the paper. So now I have the text on the slides, but I have to convey you the schemata of the probabilistic framework. So in the paper you will find definitions. If we do it probabilistically, we assume, this sample space, and we have a number of probabilities here and there, and then this is the outcome. I don't have those schemata in these transparencies, but they definitely are in the paper, so please look there. But what is the story about their probabilistic argument? Well, you can make a number of choices there, both between, of course, keeping the observations independent between the different cups, or having some dependence between these observations and having this built into your probabilistic framework. So you can choose between dependence and independence, and this can be modeled in that probabilistic framework. Another choice you can make in this probabilistic framework is how much you let it approach to the, you might say, to the original AGM qualitative setting, where you have to really make a binary decision for having your beliefs in and out. Which you might say is a boundary case of the probabilistic argument, and this they do by using non-standard probabilistic modeling, where you have some negligibly small probabilities that nicely add up, so that the final outcome is again one of the things you would originally have received when doing it the AGM way plus additional postulates. But prior to that, they also do the standard probabilistic analysis, where you simply choose some small probability of non-observed events, and then it also it nicely adds up to your required result. Well, that is the story, and but apart from that story, let me now take you through the remainder of these slides and point out some of the aspects on these transparencies that relate to what I said in the last minute, right? One nice aspect I really like is that they use these non-standard probabilities, which reminds me of a number of other work. I remember, for example, Guillaume O'Shea also had some nice probabilistic epistemic work with non-standard probabilities, right? I don't think this is referred to in their paper. They might not be aware of that. And surely there is some other work in that area. One of the things here is that, okay, here we assume that the reports are independent, and that the content of the reports are probable, and because the last report is always considered the most convincing, so to speak, then the last report should be more probable than the previous report, so you can model all this. Also, you can model it such that you can choose between having Elmer's observation, just about box 1, not about box 2, influence your observation on what's going to be, not your observation, influence your conclusion on what's going to be found in box 2, whether it's heads or tails. So all the modeling options are at your disposition here. And one of the other issues that is coming out of this excursion into, you might say, epistemic modeling. It's really a very rich array of what options do I have when I model such a simple example, and what literature from all the various works over the past 20, 30 years can I use to address this or that problem. But they don't make a final judgment, and therefore it should be done like this or like that. But no, but they address a number of relevant issues. Just to point out one of these very relevant issues is that you have to face whether to give you might say, to make the initial representation of the problem very rich, and then the dynamics very smooth and tight, or you can actually make the revision, the iteration, the dynamics part. You can model this very. You can make that very rich, but you start with an initially very smooth or tight description of the problem. So this is also a problem. Well, this I recognize because in dynamic epistemic logic you face a similar issue. If you have an action model, do I make this very complex and rich, or do I make the action model very small but the problem description very rich? So that sort of contrast. Well, now I'm digressing even a bit too much beyond, because this is not actually being written in the paper. I'm coming towards the end. Let me observe the concluding remark. So, as I said, this is like a disclaimer of formal epistemologists, right? We make no claim to a general model covering all cases. Okay, we believe that. Genuine counterexamples to AGM and iterated belief revision are cases when we cannot blame the structure of the state space. Also, in other words, therefore, there are essential aspects of dynamics where you want to tweak things in dynamics. And our eventual goal is to develop a framework in which this intuition can be used to classify these purported counterexamples, well, such as this two-cup example on which this whole presentation was based. Okay, thank you very much.
Can we go back to the very original slide where you presented an example, maybe verse number 5 or 6? Further, just forward.
No.
Forward. Yeah, that's
this one.
Yeah, that's it. Right.
Yeah.
Now, if you look at the example, then you see that the two vowels are agreeing with each other, and the consonants disagree with each other. Therefore, the vowels should be regarded as reliable, and the consonant should be discarded. That tells us that the coin is lying heads up. We know nothing about the other coin. Now, I'm not suggesting this as a serious analysis, but it seems to me that once you leave the domain of propositional, right? You have to leave the propositional domain in order to talk about two coins, because otherwise it would be just P and Q. And then why not just talk about vowels as much as you do about the coins? Once you go to the first order logic, AGM theory doesn't really say all that much.
No, I agree. And and in a way, it also surprises me. I can criticize the paper, right? Because I'm not the author, but it surprises me that they have not actually taken more advantage of the fact that these were observations made by 5 different observers. Because there are some standard approaches in AI that I know of. You assume a hierarchy of reliability between agents, and this determines your belief revision policy. So that could have been among one of the alternative methodologies to address this revision systematically, without getting to the conclusion, but well, yeah, it can be done this, that, or the other. Any
other questions? Okay, so let's thank this